Sorry. Okay, can you hear me? So I am going to record. I have to wear this dumb thing if I'm going to record. I just wanted to make a synthetic division video for the people that aren't here. Because it's not a very hard process as long as somebody explains it to you. All right, did everybody grab on your way in notes and an assignment? Yes? Okay, here we go. All right, synthetic division is a shortcut. Hey, we're ready. Put your phones away. Okay, synthetic division is a shortcut for polynomial division. Guess you didn't really care about that, except it is going to make your life easier. But there is a catch. Okay, we don't just teach you long division to make you hate math and then come along the next day and teach you the shortcut that you could use for everything. You can't use the shortcut for everything. Yeah, synthetic division can only be used when we're dividing by a binomial with a leading coefficient of 1. Okay. Yes. Oh, I guess there's three parts to that. I forgot one. When dividing by a 3 parts. Ready? Linear. What does that mean? Yeah, it can't have more than just an x. So if it's got an x squared, you can't divide by it with synthetic. Has to be just plain old x. So a linear binomial. What does that mean? 2 terms. Yes? Linear, just an x. Binomial, just 2 terms. Can only be used when dividing by a linear binomial with a coefficient equal to 1. What does that look like? Can somebody give me an example of a linear binomial with a coefficient of 1? X plus 2. Yeah. Hey, what's another example? Morgan, 1x plus 2. Yes. I didn't put the 1 on there. I'm so sorry. Is that linear? Yeah. What else would work? X minus 5. You catch the drift? X plus any number or X minus any number. That's it. That's all we can divide by when we're using synthetic division. Your worksheet last time, purple, yes? Were all of those, your long division assignment, were all of those dividing by something teeny tiny like this? No. Okay, so that's why you had to learn long division, was so you could do all those other problems. Yeah? Yes. Good question. When I show you the process, you'll understand that there isn't really a place there. To be fair, you can. But if you decide, if you want to do synthetic division by a binomial that has a leading coefficient that isn't 1, then you have to begin the problem by dividing everything in the divisor and the dividend by that leading coefficient. Synthetic division is a very artificial process. Yes, this word synthetic. What does the word synthetic mean? Like man-made, artificial. Yes. It doesn't even look like division. You don't do a single thing that looks like division in the process of synthetic division. It's fake, but it works. Okay, and the way that it works requires that that leading coefficient only on the divisor, doesn't matter on the dividend, but the leading coefficient on the divisor has to be a 1. If it's not, you have to begin by dividing both sides of that division problem by that leading coefficient, which is going to result in an amazing number of fractions. So if you want to do the process we're about to do with fractions, you can use things that don't have a leading coefficient of 1, but by the time you do that, it's actually easier to just do the long division. Yeah, great question. Any other questions so far? We good? Okay, instead of actually, I'm going to do one more piece of notes and then we're going to do an example. So we are going to use the coefficients. Okay, what are coefficients? Numbers. They're the numbers in front of the letters, yes? So we are going to use the coefficients to help us with this division process. Again, it's not going to look like division. I'll show you that in just a second. Okay, so the first thing we're going to do, if we are dividing by, let's say, actually, let's just write it like this. We're going to take a dividend. Dividend. Why does that look weird? Did I spell that right? Yeah. Divided by, let's call it x minus k. We're just going to use k as just a placeholder for whatever that integer might be. Okay, if that's the problem I'm asked to do with synthetic division, then the first thing I'm going to do is set it up. And the setup, we use a bar like this. Okay, it's going to look kind of weird. Again, very artificial. We're going to put not negative k, but positive k right here. If I'm dividing by x minus k, then I put positive k. If I'm dividing by x plus k, what do you think I put here? Negative k. You change the sign. Okay, it's what we call the zero of the divisor. If you had set, let's say we were trying to divide by x minus 5. The zero of x minus 5 is what? 5. Yeah, it's whatever number makes that factor equal 0. So if x is 5, then that factor would equal 0. So in this case, if x is k, k minus k would be 0. Yeah? So if it's plus, it's just the opposite. We're just going to use the negative sign because that's what would cancel that out and make a 0. Good? Okay. So that's what goes on the outside of the box. Inside here is strictly numbers, no letters. So your polynomials have a bunch of x's. X's, x squareds, x cubes, x to the 4th, all kinds of craziness. We only use the coefficients in front of them. So right here along this top line, we're going to have the coefficients of the dividend. They're on the back counter. We doing okay? Okay. That's the setup. That's what it looks like when you begin. When you're done doing this process, your answer is going to be made up of the numbers that are down here. When you're done, down here you will have the coefficients. Thank you so much. Of the quotient of your answer. Oh, she's not here. Where is Ashley?
I don't know. I saw her out at lunch.
Yeah, she's probably not going to be a cheerleader for very long. Just kidding. I don't know. I don't know what she's doing. Of all the classes to skip, Ashley. Okay. So we take the coefficients of the dividend, and then we're going to do a process, and we're going to end up with the coefficients of the quotient. Do you remember our discussion on placeholders last time? Okay, do you remember how it was a big deal? This is an even bigger deal. When I say coefficients of the dividend, please triple star, triple asterisk, super important. Don't forget what? Placeholders or whatever you want to call them. Now, I overemphasize it with synthetic because when you're doing long division and you forget your placeholder, 99% of the time you catch yourself. You go to multiply back down and you get x squared, but you're in an x column and you're like, wait, why? Why do I have an x squared sitting under an x? That doesn't make any sense. Oh, it's because I forgot my x squared placeholder. On this one, you don't have those x squareds attached to it. You would never see that you missed a placeholder. Okay? These coefficients have to go all the way from the highest degree down to the constant. Even if the polynomial ends with an x, you have to put a 0 at the end. You have to have a placeholder even for that constant piece. Good? There are lots of placeholders needed on today's assignment. Please don't forget any of them. Okay. All right. So this is the setup. Now I'm going to actually show you how to do it, but I'm going to show you how to do it. I'm not going to write out all the step-by-step instructions. If you really want all those words, these completed notes are always available on Canvas for you. Okay. I'm not going to do that. I'm just going to do the problem with you because as soon as you see it done once, at least half of you will be ready to go. As soon as you see it done twice, the rest of you will be like, oh, I got this. Easy. Okay. All right, here we go.
You know what it puts me through?
Doesn't even come close to football practice. Let's just. All right. Oh, seriously, the screeching. No, it doesn't.
Oh, yeah. So good.
All right. Synthetic division. Here we go. Did I turn it all the way down? Hello, hello, hello. Okay. It was weird. I turned it back up and then it didn't seem like it was on, but it is. I don't sing ever, not even apple bottom jeans. It's not serious singing though, it's a joke. Okay, here we go. Setup. Raise your hand if you can tell me what goes in front of that box. A positive 2. What the hell? Yeah, where'd that come from?
You switch the sign when you're putting it.
Divisor, yes?
Yeah.
First of all, let's check it. Is it linear?
Yes.
Yes. Is it a binomial? Does it have a leading coefficient of 1? Okay, so we can use synthetic division. Then we just change the sign and put it in the front. Okay, what goes next to it but inside the box? Coefficients of the what? Dividend. And what are the coefficients of the dividend? The first one is 1. Okay, watch. This is what happens in my head every single time I do one of these problems. The first coefficient that I write down, first of all, don't even attempt to try until everything is in standard form. I'm never going to give you one that's not in standard form, at least not on purpose. Okay, they should already be in standard form. So your highest exponent should be first, but if for some reason it's not, please put it in standard form first. So 1 is the coefficient on my highest exponent of x cubed. Because that's a 3, in my mind, I'm doing like the little Einsteins send the rocket. So I'm like 3, 2, 1, blast off. If you don't get all the way down to blast off, you're missing something. Okay, so this is my third power, second power, first power, blast off, yeah? Make sure you get the coefficients from all of those. If you're counting down like that and maybe you're starting at 4, 4, 3, and then you realize there isn't a 2, put a 0 in there. Feel good about it? Okay. All right, now the fun. You ready? First step of synthetic division, once you've got it set up, is to drop it like it's hot. You just drop that down. You literally do nothing to it. You just drop it. Okay? The rest of this process is multiply, add, multiply, add, multiply, add, multiply, add, until you run out of numbers to multiply and add. Did I say division one time? Is that weird?
But I mean, when you think about it, it's not that far off the actual step.
It's a little.
Minus 2, we switch the signs. I don't know if that's actually why. That's how I'm reading.
Okay, so what did I say my next steps were? So I'm going to multiply. Ready? 2 times 1. Multiply. 2. What do you think we're going to do now?
Add -3.
Add. -1. Repeat. Now what I'm going to, oh, hold on. We're going too fast. Slow it down. Now what do I multiply? Yeah, 2 now multiplies the -1. Where do I put it? And what do I do with those two numbers? Oh my gosh. Basically brilliant. What's -7 add -2? Thank you. And now what? Do it again. Holy cow. It's like it's easy or something. Add. When you're done with long division, the very last number you write is your what? Remainder. Same with synthetic division. The last number you write is your remainder. Was that hard? I mean, if you suck at multiplication and addition, it's going to be a rough day. Otherwise, you'll be fine. It's not an answer. What? My answer can't just be 1, -1, -9, -12? You're right. I need to put the x's back on it. Same way I pulled the x's off of here, I need to put them back on here. But I have a question. This first one was the coefficient on an x cubed. Do you think this is supposed to be an x cubed? It'd be x squared because we divided by an x, right? We divided a third degree polynomial by a first degree polynomial, which brings it down a notch to a second degree polynomial. So there's a couple ways to look at it. If this is your remainder, then this has to be your constant, then this has to be your x, then this has to be x squared. Or you can just always remember whatever the exponent started as. If you did it with synthetic, it always drops 1. Okay, so how do I actually write my final answer? Is there an x on this one? Yes or no? No, this should be a constant. And then I taught you guys this little tidbit last time. What's safest right here? The safest is to put a plus sign, put the remainder in its entirety on top, and the divisor on bottom. Okay, in this particular situation, listen carefully, there is nothing wrong with that, except that my minus sign was very crooked and wiggly instead of straight, but whatever. She's a curvy girl. That's what I said today. I had to give this packet to my stats students. And I said, before I hand her to you, just be aware that she's a little thick, like 2 C's, like a little bit thick. Anyway, yes. And then there's my curvy girl. Okay, let's try harder. Oh, look at that. Okay. Anyway, there's nothing wrong with this. Okay. But if your remainder from long division has 2 or 3 terms in it, this is dangerous territory. Because in order to put a subtraction here, you would have had to factor out a negative out of every term of that numerator. Okay. When it only has 1 term, it's not going to hurt anything. But safe, put a plus sign here, put the whole remainder up there. Don't worry about anything else. Well, because some people just, like, you wrote this as minus, you didn't write it as plus negative 1x and plus negative 9. It's the same concept. Like, it just feels natural. Okay, that's a negative 12, so minus. It doesn't matter. Yeah. Any questions? Yeah. Yes. In 2 class periods, so next Friday, we will do synthetic division all day. And you will do it on 1 problem 3, 4, 5, 6, 7, 8, 14 times if needed. It's pretty fun. Yeah, most of the time you're using synthetic division to find something that works. You're waiting and waiting and waiting and waiting for a 0. What would a 0 indicate right here? No remainder. But what does no remainder mean? It divides perfectly. So does x minus 2 divide perfectly into that polynomial? No. Okay, so it's kind of like, let's flash back to like, oh, I don't know, maybe 3rd? What grade? No, it would be more like 4th. 4th-ish, 5th-ish, 4th-ish division. Okay, if I asked you a question, if I asked you to do 10 divided by 2, is that going to have a remainder? No, that's just 5. Okay, 10 divided by 3, however, it's 3 with a remainder. You probably learned like that hideousness. Don't ever do that in my class, please. Okay, it's really 3 1/3. This is your remainder piece, right? It doesn't divide in nice. Well, when something does divide in nice, you could rewrite this division problem as a multiplication problem. What would the multiplication problem be? 2 times 5 equals 10. One of your main jobs in this whole entire class, like all year long, is to factor. Factor literally means to write in multiplication. Okay, so we use synthetic division to test numbers to see if they divide in nicely, because if they divide in nicely, then I know that that factor is one of the things that can be used to rewrite the big polynomial as a product. This factor times this factor equals this product. Okay, so that's that's the other piece that you're going to do today. Not only are you going to do synthetic division, but it's so easy. We didn't want you to just do that and get bored. Okay, so there's a little bit of an extension in understanding what it all means. Yeah? Okay, so let's do another one. Let's go to the next page on your notes and pick another problem. That is such a cute noise. I think we should do that all day, every day. Why are we not doing 5? What do we write on number 5? If they ask us to divide it using synthetic division, we say, not possible. We say, no, thank you. We say, do it yourself. No. Okay, so instead, 2, 3, or 4, pick one. 2's at the top of the paper. For those of us that are OCD, let's just start at 2. When you have thumb wars, do you have to bow and kiss?
I
1,
know
2,
what
3,
you're
4. Let's declare. I declare a thumb war. 5, 6, 7, 8.
Thumb straight. Bow. Kiss.
Anyway, my son got mad at me because I don't do like the bow, kiss, begin. I just like grab his thumb and pin it down. And he's like, that's not fair. I didn't know I had to bow and kiss before I could pin you to the ground. I know. Is that what you guys do when you go up to the coin toss? Do you bow and kiss before you begin?
That would be really funny.
Can you imagine? They come out with a new rule. From now on, when captains meet in the center of the field or the court, you must bow. Okay, too funny. Okay, moving on. We proceed. Let's synthetically divide. These poor people that are watching this video after the fact will be like, she's crazy. Fine. I don't mind. All right. Tell me how to set it up. 3 or negative 3? 3 or negative 3? 3 or negative 3? I wasn't yelling at you. Okay, 3. Now what? Okay, here we go. What goes here? Negative 1. 4. 0? Why 0? 3, 2, 1. Oh, there is no 1. 0. Yes? What happens if you forget your placeholder?
Then it doesn't work out. I get that.
Then you have no idea. Here's the problem with synthetic division. You forget your placeholder, you have no clue. You do the problem, you get a totally different answer than everybody else, and we're all looking at you like, yeah, you messed up. Okay? But you will never catch it yourself. It won't be there. You won't see it yourself. Okay? You have to check. You have to triple check every synthetic division problem. Okay. Step 1. Say it a little louder.
Like it's hot.
Thank you.
Yeah, I got it.
Drop it like it's hot. And now what? 2 things over and over again. Multiply, add, multiply, add, multiply, add, multiply, add until we're done. Multiply what? 2 numbers. 3 times negative 1 is negative 3. Add them. 1. Multiply them. 3. Add them. 3. Multiply them. 9. Add them. 18. Or we could do long division. It only takes up half a page, but you know, it's fine.
Yeah, I'd rather not. I like this way.
What's the answer? What is the quotient? Ready, go.
Negative 1x squared plus 1x. Oh, but you don't have to add those. It's a positive 3, right? It's a positive 3 plus 3
Yeah, that's fine.
plus
Kinda change that.
18 would be.
I didn't put the 1s. I never will because I think they're ugly. I can never decide when I'm writing a 1 if it's this or if it's this. And it drives me crazy. It's fine.
The second one looks better.
Good? I know, right? Me too. Okay. Any question about how synthetic division works? Any question about when you can and cannot use synthetic division? Any question about when you should use placeholders? Okay. All right. Now I'm erasing. Are we good? Okay. Now the next 2 types of questions that you will come across when using synthetic division. So go to page 3 of your notes, I believe. Okay, remainder theorem. I'm not going to write down the official definition. I'm going to show you how it works. You might want a calculator for this. Okay, I would like it if you did it by hand, but I understand completely if you would rather just use a calculator. I would like you to take this function here and evaluate it at -4. Please tell me you know how to do that. I would like you to take f of x here and evaluate it at -4. Just substitute the -4 in for the x. Simplify it down till you get a number. It is not a cute number. I will tell you that up front. That was coming. Sorry. Everyone should be evaluating. I don't know if you can evaluate this and talk at the same time, so quit talking. Yeah, Morgan. You're gonna get kicked off the cheer squad. What? No? If you use the parentheses, you can type it all in at once. We're not tired, Morgan. What are you talking about? No, I'm just tired. Nope, just tired. I already messed up. Wow, I feel so cool right now. I knew what the answer was supposed to be. I pushed equals and it didn't show up and I was like, oh, why? There we go. Did you get a beast? Did you get -359? Well, that's what it is. Can we discuss order of operations just teeny tiny bit? Let's just do this first term right here. 5 evaluated at -4. We've got a -4 raised to the third. Multiply or exponent? Exponent. Good. So what's -4 times -4 times -4? It's -64 needs to be multiplied by a 5. That's like -320. That's step 1 of the 4 steps you still have left. Good job. So enthusiastic. -16. Why is it minus and not plus? The -4 gets squared, making it +16, but then there's a subtraction sign ahead of that. So -16. Plus 13 times -4, so -52. And then plus 29. -359. Isn't that adorable? Aren't you glad we did that one? Okay, now I am not going to say a word, but I'm going to do something. I want you to watch it. Ready? Are you watching? Are you watching? The magic is about to happen. Okay, here it is. Shh. Don't tell me what I already know. Oh, except I don't know that. 97 times 4, help. What is it? Shh, stop. Now subtract 29 from 388 for me. Well, really, the more important question is it right? Yeah, it is. We did it right. I did it right. This is what we call the remainder theorem. If you are trying to evaluate a function at a particular value, in this case, -4, you synthetically divide by that number. Okay, so when did I change the sign? When it looked like what? When it looked like x plus 3, or when it looked like x minus 7, then I definitely changed the sign. Does this look like that? No, it wanted me to evaluate when x equals -4. It's not in what we call the factored form. It's not written as a binomial, so you're not finding the 0 of it. You already have solved for x. X is -4, so -4 goes on the outside. I synthetically divide, and what I get as my remainder is exactly what I got by plugging it into the whole function. Strange. Okay, so let's review for just a second. If I do this, if I plug in -4, do you recall that if I'm not making you do this one, but if I needed to graph this particular function, is it not true that I have just discovered that there is a point for this function at -4, -359? Right? When I plug in an x value and it spits out a y value, I have just found an ordered pair that exists on the graph of that lovely f of x up there. Agreed? I might not know anything else about that graph, but I do know it goes through this point. Okay, so using synthetic division can do that same exact thing for me. Synthetically dividing by a -4 gives me the output of -359. This is also an ordered pair that I can use, even when that wasn't my intended purpose. Okay, so the problem we just did a second ago, I'm stealing your notes. Okay, the problem we just did a second ago, we plugged in a 2 and our remainder was a -12. Okay, so even though it wasn't the answer to that question, and even though I didn't necessarily need that information, I now know that for whatever this function is right here, it goes through the point to -12. Okay, synthetic division is always going to give you that. It's called the remainder theorem. Whatever number is here, that's your f of that number will always equal the number that you have on your remainder. Always. It's the exact same thing as plugging that number in, substituting it into the function. You feel okay about it? Yes. Yes. Yep. So if you're ever asked to use synthetic division to evaluate and you're not 100% sure that you did your synthetic right, then you can substitute to evaluate. Or if you're ever asked to substitute to evaluate and you're not sure if you did it right or if your calculator is working right, because I know you guys hate these calculators, then do this instead and see if you come up with the same answer. Okay, they do the exact same job when you just look at the remainder. Okay, so there's one more thing, and I kind of alluded to this a second ago. Jump down to, does it say factor theorem on that same page? Okay, jump down there. So do you remember earlier? Do you remember the conversation about is 2 a factor of 10? And the answer is yes. Why? How do you know that 2 is a factor of 10? Okay, because 2 times 5 is 10, but also because 10 divided by 2 doesn't have a remainder, right? That's part of the solution right there. Okay, so let's try this one down here. Yeah, no, wrong direction. Oh my. I actually don't care about the definitions. We can get those later. Okay. Determine whether or not x minus 2 is a factor. Okay, look. Are you looking? You see this? So what goes here? 2. Why am I changing the sign? I just barely did one where I didn't change the sign. Just barely, it said x equals -4, and I put a -4 right there. I didn't change the sign because that was what x equals. This is not saying x equals 2. This is saying is x minus 2 a factor. So what do I have to put out here? The 0 of that factor, a 2. Okay, tell me what goes in the box. What numbers? 1, 2, -4. Am I sure I didn't need any placeholders? 2, 1, blast off. Okay, we're there. Now what? Drop it. Multiply it. And that gives me 4. The question is it a factor? And if it's a factor, that means it divides in perfectly. Did it? No. Okay, this right here, this is my answer. No. Period. You could put absolutely not. Right. Because if it's 0, it did divide nicely. And the answer is yes, it is a factor. Okay, so this right here is telling me, so do you guys remember factoring? That's supposed to be a 4. Do you remember when we would take something like that and turn it into something like that? Okay, so this is telling me right now that if this was to factor, it's not going to factor into x minus 2 times something. This is not a factor of that polynomial. Yeah? Does this factor? Do you guys remember how to factor? Okay, if they have something, but in this case they don't. So you would, most of you learned multiply a times c, which is what? 1 times -4, so -4. And then find factor pairs. 1, -4, -1, 4, 2, -2. Do any of those add up to +2? So not only is x minus 2 not a factor, this just doesn't factor. There aren't two numbers on this list that both multiply to -4 and add to 2 at the same time. Okay, so this one is not factorable. It's what we call an irreducible quadratic. Big fancy words. We'll practice using big fancy words next time. Okay, so let's look at this. I'm just going to throw another example on the board really quick. Do you guys remember, do you think you could factor this one for me? If I promise you it does factor, do you think you could possibly factor it for me? So does everybody know x and x? Yes, for sure we know that. Without a big fancy a times c and split the middle and factoring by grouping, all that big stuff that you learned last year, is there any way you could just factor this? -2, -3. Why? What do those two numbers do? They add up to -5. They also multiply to give me -6. I mean 6, not -6. It only works if there's a 1 right here. Otherwise, a times c has to happen. Yeah? Well, there are other ways to do it, but a times c is like your go-to, this will always work process. This is a shortcut. Okay, so I have a question. Tell me what's going to happen if I put a 2, 1, -5, 6. You guys paying attention? Don't work on your assignment. Pay attention. What's going to happen if I do this? Where did I get these numbers from? This is going to be what factor? X minus 2. So the binomial x minus 2, my question is it a factor of x squared minus 5x plus 6? And the answer is yes, which means when I'm done with my synthetic, what am I going to have? No remainder. Drop it like it's hot. Multiply. Add. Multiply. Holy moly. Look what's left. So I just divided this polynomial by this one, and guess what it gave me? This one. Yeah, you wanna do it? 3, 1, -5, 6. Ready? Drop, multiply, add, multiply. Holy heck, we did it. It's like this game. Look, 10 divided by 2 is 5. What's 10 divided by 5? 2, because 2 times 5 is 10. Yeah, factor families. Yeah. Fun. Oh my gosh. Okay, so a few things. Let's wrap up this question. The factor theorem tells us that f of 2 in this problem is 4. That's not really what the factor theorem tells us. I don't really, sometimes the notes are a little, fine. The factor theorem tells us that x minus 2 is not a factor of f of x. That's what it tells us. We didn't get a 0. Okay, so the factor theorem tells us that because this was not a 0, x2 is not a factor of x squared plus 2x minus 4. Okay, we can find that f of 2 is 4, right? If we had substituted, we would find that same thing. We're not going to because that's a waste of our time. We already did it. We already know from our synthetic division that f of 2 is 4. If this had turned out to be a 0, then it would be a factor, and this would be 0. The output would be 0. Yeah? Which is also identifying, if you have, let's say, hypothetically speaking, that f of 2 is 0, then you have the ordered pair 2, 0 on your graph. Well, don't you remember from last year that these points right here on the x-axis were kind of a big deal? Then you'd have another one somewhere, let's just say it's over here for funsies. Then you have like axis of symmetry and vertex, all that. Yeah, those x-intercepts were a really big deal with quadratics. This is one way to find them. They're going to be a big deal with these bigger polynomials too, not just quadratics. So 3 things today. Can you synthetically divide? Do you know the rules for when you can and cannot synthetically divide? Good. Step 2, can you tell me, can you evaluate a function using synthetic division? Remember, we don't change the sign. Yeah, just synthetically divide. And where do you get the answer from? Remainder. When you're actually dividing, your answer is the whole polynomial that you need to put back together. But if it's just asking you to evaluate the function, your answer is whatever number is chilling right there. Okay, 3rd thing you're going to do on this assignment is determine if a certain binomial is a factor of the bigger polynomial. And how do you do that? Synthetically divide and pray for what number? 0. 0 is a factor. Anything else? Not a factor. Can you do it? Okay, do it. Get your assignment done.